So I'm a software engineer at Walmart and a fresh graduate from IIIT Hyderabad last year. I have previously interned at Beethoven and Hotstar. I'm also an amateur musician and I play the keyboard, guitar, and the bassuri, which is the Indian flute. Outside of that, I spend a lot of time building tools around music, especially Indian classical music. So, first of all, I would like to play a sample of Carnatic music for those who haven't heard of it. So, this is an alapana in Raga Kapi. And if you have observed, there is no rhythm here. It's just a free flowing exploration of raga. And notice how the pitch is continuous and the notes glide into each other, unlike Western music where you have discrete notes. And how the same note is never sung exactly the same way twice. So there is a subjectivity in rendition. So this expressive fluid nature is what makes the music beautiful, and it also makes it very hard to model computationally. So that is the core challenge that we will be keep coming back to in this talk. So in this talk, I'll walk through a few approaches that I explored. Think of it as a timeline of projects, each making different design choices. And it's all about Indian classical music and symbolic representations for those. So one of my earliest projects was something I called Swar Composer. So the idea was simple. Uh, I would enter North Indian classical music notation into it called Swarlipi. So I built a parser that could read the notation and play it back using MIDI. So it supported external MIDI players too, and we could visualize the music in a synthesia-like format. So the pipeline was simple. You write notation and the computer plays it back. So you get pretty visualizations also. And this is the next version of it. Because everything was structured in the previous pipeline, you can easily extend it. For example, adding a tabla track. So from a systems perspective, this is a modular pipeline where the first step is to parse notation. Second step is to map individual MIDI pitches to each swara. And third step is to add rhythmic structure to it based on the tala selected. And fourth step is to render audio and MIDI together. This all went well, but this kind of sounds boring because as audio developers, we naturally move toward audio and we like expressive renditions and rich renditions. So this is an example what I built before. So you could enter classical music notation into it and it would play along with the tabla. And this is some of my different kind of approach where I used web technologies to build interactive instruments. On the left is a flute app. It uses multi-touch for finger positions. It's a mobile app. So you can keep all your 6 fingers on the screen and then blow into the mic. So the amplitude of the mic, the app detects and plays the note which you are holding. And if you blow harder, it will play the next octave as a flute should play. And in the middle, you have a hand gesture instrument. In this case, your index finger controls the pitch, and the camera tracks your movement. And the distance between index finger and the thumb controls velocity. So this is kind of a two-dimensional expressive instrument. And on the right is a touch-based slider where you can move freely your finger on the screen, but the notes that are available are constrained to a raga. And sometimes in ragas like Desh, where the ascent and descent are different, the right side of the screen will be ascent and the left side will be descent. So even if you play freely, and randomly it sounds like the whatever you play is in a raga. So what I found interesting here was we can utilize multiple modalities like touch, vision, and audio, like I just showed, using everyday devices. So being on the web also make these apps accessible. These are all based on web technologies. But when we move from interaction to understanding, things get harder. So let's try music understanding using notation. So until now we have seen playback and interaction. So this third app of mine allows you to play uh, the on-screen keyboard to enter notation. And starting with notation, it does something simple. It extracts n-grams from notation, which are just a sliding window, and matches against the database of different ragas. And the match with the highest count is the most probable raga. So this is a basic raga recognizer that I had made, and it works just through notation. Then we try the harder task of doing that through audio. So now the flow looks like first the audio waveform, which you will get through the mic or any audio file. And then you extract the pitch, so pitch detection, and you try to segment each individual note. And then using the notes, do the same thing that the previous pipeline was doing, which is pattern matching. But here we see an example. I'll show you how that worked.
झाकल्या मुठीत काही, झाकल्या मुठीत काही, गोड सुख रामने, गोड सुख रामने. दुःख तीर दूर जाई, दुःख तीर दूर जाई.
So as you saw, initially I played the original audio, and then later the synthesized detected pitch was layered on top of it, and then the original audio was removed. So this way we can check if the pitch detection is working properly, and we saw how the notes were segmented. But in this process, getting good results is not that reliable because slight alterations in pitch can make note detection hard. And this is where things get difficult because Indian classical music is not made of clean and discrete notes. So we have three main problems, which is continuous pitch, which means that one note flows into the other note seamlessly. So you don't know which note is which. And we have ornamentation on a single note, which is called gamakas. And we have variability. That is, the same phrase can appear in many forms depending on the person who is rendering. So even something as basic as what note is being played becomes ambiguous. And this leads to the first key takeaway that we have, which is audio is expressive, but it does not give you clean structure to do any analysis on unless you do some high pre-processing. So the question becomes, can we work with a representation that already has structure instead of trying to infer structure from audio? To answer that, let's look at different representations that we have. So in general, we can think of two kinds of representations, symbolic and acoustic. And the main difference is symbolic representations are already discretized and structured, and they are also easy to modify, whereas acoustic ones need a very specific pre-processing based on the task on hand. And descriptive notations and prescriptive notations are two types within the symbolic domain. And we generally see that the descriptive notations tell the performer exactly how to play. So there will be minimal difference across different renditions by different people of the same notation. And prescriptive notation only tells the performer what to play. So the final output will be subjective, which is largely the case in Indian music. So any composition that you have will be sung differently by different people. I just want to highlight that we have made a lot of progress in standardizing sheet music for Western music. Today, sheet music is not just an image; it is found in different formats like music XML, which represent notes and timing and expressions in a structured and machine readable way. And that makes it much easier to analyze and build tools on top of it. But we really need something similar for Indian classical music. Before going further, let's take a look at how music information retrieval typically works in an audio domain. I have borrowed this slide from Ajay's keynote from last year. So most MIR pipelines start with audio and then try to extract structure from it. In the top, you can see for melody, we try to derive melodic descriptions like segmentation, similarity, and motif discovery. And in rhythm also, we try to extract meter patterns and high-level structure. The common pattern here is we start with a continuous signal and try to rediscover discrete structured information behind it. So this is exactly where the things have become difficult for ragas, where because signal itself is highly expressive and it has ornamentation and variation as previously said. So instead of always extracting structure from audio, the question I started asking was, what if we start with structure directly, like the symbolic notation directly? Let's think about it. How do musicians actually learn and work with ragas? They of course follow the oral tradition of Guru Shishya Parampara, but along with that, we also use notation for teaching, for composition, and for archival. Now, because notation we can see that it is written in text format. So, can we treat notation like language? If yes, for an audio developer, this is a powerful idea because it lets us reuse an entire ecosystem of NLP tools. That means we can apply NLP to music. Notes becomes tokens, phrases become engrams, and ragas become documents. But for an accurate analysis, we need accurate data in large quantities. So here comes our paper where we built a data set of over 2200 notations from 7 sources covering 337 ragas across Hindustani and Carnatic traditions. And this required a lot of cleaning and normalization by experts, and it also enabled large scale symbolic analysis for us. So once you have a good symbolic data like this, a lot of things become straightforward. For example, generation. You can build a composer using n-gram models, and because you're working with discrete sequences like individual notes, sa, re, ga, ma, so local dependencies will be modeled, and I'll play an example generated in Raga Shivranjani. So both the rhythm and melody part is coming from the n-gram model, which is trained on some composition in Raga Shivranjani, and everything is just notation. So we can also experiment with harmony by combining scale constraints and rhythmic structure. For example, if we have a raga asavari and we want to create chords for it, then we can use the possible notes in that scale. And the tala basis, we can use different vibhags. The starting point of vibhag we can use as a chord strum. And I would like to show you this example. So basically what happened here was just the notation was given, the right hand part, and the tala markers were given where each beat lies, and the algorithm played chords by itself. But this is exploratory, so it shows that you can have additional musical concepts based on top of a basic structure that you make of notation. And now let's quickly run over some tools which you can use, not necessarily NLP. So this is the idea of TPMs, where you create a transition probability matrix of which note is going to where. So if you have Sarega, Sa to Re is a transition, Re to Ga is a transition. So you compare that for different ragas. So for Desh and Bhupali, you see it's different. For Deshkar and Bhupali, you see it is similar because Deshkar and Bhupali are similar ragas. So you try to calculate distances based on it, like KL divergence or some other metrics. And then another way is to use TF-IDF. This is an idea from NLP where each term and document, you can find the importance of a term within a document. So basically, for a raga, you have a sequence of notes, and for each sequence of notes, you create the different words, which are like n-grams, and then try to give importance to the words compared to all other ragas. So distinctly unique phrases in a raga like show up with high value. And using those numerical representations for a raga, you can try to plot it on a big graph because we have like 337 ragas we can just plot. And what we saw was interesting, like similar ragas are clustered together and different ragas are far away. So that is one observation and we saw. And also similar ragas across traditions like uh, Yaman and Kalyani, Hindustani and Carnatic are like very close, if you can see here. And yeah, basically that was my presentation. So next step from here, what we can do is do better audio and symbolic combined pipelines and better modeling of ornamentation like gamakas, and better control systems like MIDI polyphonic expression, so that each channel will hold a single note and all notes can have different expressions of their own. So that is more suitable for Indian classical music. And the conclusion is that audio is expressive and ambiguous, but symbolic music is also like useful because it's structured, learnable, and even though it is incomplete, we can have some high level analysis on top of it. So best systems would combine both approaches. And yeah, thank you. That was my talk today.